The universe has always been a place of mystery, a vast expanse of darkness punctuated by the faint glimmers of stars and galaxies. For centuries, humanity has gazed up at the night sky, wondering what lies beyond the reach of our eyes. We've built telescopes, sent probes into the void, and crafted theories to explain the origins of everything we see. But despite our advancements, we are nowhere near as smart as we think we are. 14 billion years ago, something extraordinary happened. The Big Bang. And yet we still don't know what came before it. Our universe is still growing, still expanding, and we are left with one burning question. Why did the Big Bang happen? It's possible that the biggest problem is that we can't see the Big Bang directly. But science hasn't given up yet. In fact, the James Webb Space Telescope has taken the first steps toward capturing what is thought to be the echoes of that monumental event. What kind of power does this telescope hold? What does this mean for the future of astronomy? Come with us as we dive into this groundbreaking discovery, a device from the future that might just change everything we know about the cosmos. To understand the significance of this discovery, we must first grasp the importance of the Big Bang itself. What is it about this singular event that has captivated scientists for decades? The Big Bang theory is the most widely accepted explanation for the origin of the universe. In simple terms, it suggests that the entire universe began as a single point of infinite density and heat. This unimaginably small point underwent a rapid and explosive expansion, growing faster than the speed of light in its earliest moments. Over the course of 13.7 billion years, this expansion slowed, giving rise to the universe we see today. A universe that is still growing, still evolving. But here's the catch. We can't directly observe the Big Bang. Our current technology limits us, and much of what we know comes from mathematical models and indirect evidence. That is, until now. The James Webb Space Telescope has changed everything. This marvel of engineering has allowed us to peer deeper into the cosmos than ever before, capturing light that has traveled for billions of years. But before we delve into its discoveries, let's take a step back and understand the foundation of our knowledge. Long before the James Webb Telescope, astronomers discovered the cosmic microwave background, CMB, a faint glow of radiation that permeates the universe. This afterglow of the Big Bang was first predicted in 1948 and accidentally discovered 2 decades later. It remains one of the strongest pieces of evidence for the Big Bang theory. Yet even with this evidence, the theory has its critics. Some propose alternatives like eternal inflation or an oscillating universe, theories that challenge our understanding of the cosmos. These debates highlight the complexity of the universe and the questions that still remain unanswered. More than 13.7 billion years ago, the universe was a singularity, a point of infinite density and heat. Then, in a fraction of a second, it underwent a rapid expansion known as cosmic inflation. This era, lasting only a few hundredths of a second, set the stage for the universe as we know it. As inflation ended, the universe entered a phase of reheating, where matter and radiation began to form. This was the birth of the building blocks of everything we see today: atoms, particles, and the seeds of galaxies and stars. The temperature during this time was mind-boggling, reaching around 10 billion degrees Fahrenheit. In this primordial soup, particles like neutrons, electrons, and protons swirled, destined to become the foundation of our universe. But for the first 380,000 years, the universe was opaque. Light couldn't travel freely because free electrons scattered it in every direction. It wasn't until these electrons combined with nuclei to form neutral atoms that light could finally shine through. This moment, known as recombination, marked the birth of the cosmic microwave background, the first light of the universe. It's this light that the James Webb Telescope is now capturing, giving us a glimpse into the earliest moments of existence. On July 12, 2022, the world witnessed the first images from the James Webb Space Telescope. These images, showcasing the Carina Nebula, the Southern Ring Nebula, Stephan's Quintet, and a galaxy cluster that warps the light of objects behind it, left the world in awe. But it was the discovery of the oldest galaxy ever observed that truly shocked the scientific community. This galaxy, formed just 300 million years after the Big Bang, offers a window into the universe's infancy. The James Webb Telescope, positioned 1.5 million kilometers from Earth at Lagrange Point 2, is uniquely equipped to observe these ancient objects. Unlike its predecessor, the Hubble Space Telescope, which primarily observes visible and ultraviolet light, the James Webb Telescope specializes in infrared light. This allows it to see through cosmic dust and capture the faint light of distant galaxies. The James Webb Telescope's design is nothing short of revolutionary. Its 18 hexagonal mirrors, arranged in a honeycomb pattern, provide a collecting area 6 times larger than Hubble's. Combined with its advanced cameras and a massive sun shield, the telescope can peer deeper into the universe than ever before. It's designed to observe the universe as it was just 100 to 250 million years after the Big Bang, a time when the first stars and galaxies were forming. This capability has already led to groundbreaking discoveries, challenging our understanding of the early universe. One of the most shocking revelations from the James Webb Telescope is the existence of massive galaxies in the early universe. These galaxies, observed just 500 to 700 million years after the Big Bang, are far larger and more complex than current models predict. According to our current understanding, the universe was too chaotic in its early stages for matter to settle and form such massive structures. Yet, the James Webb Telescope has found galaxies with masses up to 10 billion times that of the Sun, some even rivaling the size of our own Milky Way. This discovery has left scientists questioning their models and rethinking the timeline of galaxy formation. What does this mean for our understanding of the universe? It suggests that the early universe was far more dynamic and complex than we ever imagined. The existence of these massive galaxies challenges the idea that the universe evolved slowly over time. Instead, it points to a universe that was capable of forming intricate structures much earlier than previously thought. This discovery has sparked a wave of new research as scientists scramble to update their models and theories. But the James Webb Telescope's discoveries don't stop there. It has also provided unprecedented insights into the formation of stars and planets. By observing distant exoplanets, the telescope has revealed the chemical composition of their atmospheres, offering clues about their potential habitability. It has also captured stunning images of star-forming regions, shedding light on the processes that give birth to new stars. These observations are not just expanding our knowledge of the universe, they're reshaping it. The implications of these discoveries are profound. They challenge our understanding of the universe's origins and evolution, forcing us to rethink long-held theories. They also raise new questions about the nature of dark matter and dark energy, the mysterious forces that make up the majority of the universe. As we continue to analyze the data from the James Webb Telescope, one thing is clear. We are on the brink of a new era in astronomy. The James Webb Space Telescope is more than just a tool for observing the cosmos. It's a window into the past, a time machine that allows us to witness the birth of the universe. Its discoveries are not just changing our understanding of the cosmos, they're changing the way we see ourselves. We are no longer just observers of the universe, we are participants in its story. And as we continue to explore the mysteries of the cosmos, we are reminded of how much we still have to learn. The James Webb Telescope's biggest discovery is not just a single image or observation. It's the realization that the universe is far more complex and mysterious than we ever imagined. It's a reminder that we are still at the beginning of our journey to understand the cosmos. And as we look to the future, one thing is certain. The James Webb Space Telescope will continue to reveal the secrets of the universe, one discovery at a time. So, what do you think? Will the James Webb Telescope's discoveries change everything we know about the universe? What other secrets might it uncover? Share your thoughts, and don't forget to stay tuned for more updates on this incredible journey into the cosmos. The universe is waiting, and the James Webb Space Telescope is just getting started. The James Webb Space Telescope is not just a marvel of modern engineering, it is a beacon of hope for humanity's quest to understand the universe. Every image it captures, every spectrum it analyzes, and every discovery it makes pushes the boundaries of our knowledge further than ever before. But what makes this telescope so extraordinary is not just its ability to see farther, it's its ability to see differently. By observing the universe in infrared light, the James Webb Telescope can pierce through the cosmic dust that obscures our view, revealing hidden galaxies, ancient stars, and the faint whispers of light from the dawn of time. And with each new observation, it challenges our assumptions, forcing us to rethink what we thought we knew about the cosmos. One of the most astonishing revelations from the James Webb Telescope is the sheer abundance of galaxies in the early universe. Before its launch, scientists believed that the first galaxies were small, faint, and relatively simple. But the telescope's observations have turned that idea on its head. Instead of finding a handful of dim, primordial galaxies, it has uncovered a universe teeming with bright, massive, and complex structures. These galaxies, some of which existed just 200 to 300 million years after the Big Bang, are not only larger than expected, but also appear to be forming stars at an astonishing rate. This discovery has left astronomers stunned, as it suggests that the early universe was far more active and dynamic than anyone had predicted. But how could such massive galaxies form so quickly? According to current models of cosmology, the universe was a chaotic and turbulent place in its infancy. Matter was spread thinly, and gravity had not yet had enough time to pull it together into large structures. Yet, the James Webb Telescope's observations seem to defy this logic. Some of the galaxies it has observed are so massive and well-formed that they challenge our understanding of how galaxies evolve. Could there be something missing from our models? Could dark matter, the mysterious substance that makes up most of the universe's mass, have played a more significant role in the early universe than we thought? These are the questions that scientists are now grappling with and the answers could reshape our understanding of the cosmos. The telescope's ability to observe the chemical composition of distant objects has also led to groundbreaking discoveries. By analyzing the light from ancient galaxies, scientists have detected the presence of heavy elements like carbon, oxygen, and nitrogen, elements that are essential for life as we know it. This finding is particularly surprising because, according to our current understanding, these elements should not have existed in such abundance so early in the universe's history. Heavy elements are forged in the hearts of stars and scattered throughout the cosmos when those stars explode as supernovae. But the James Webb Telescope's observations suggest that stars were forming, living, and dying at an incredible rate in the early universe, seeding it with the building blocks of life far sooner than anyone had imagined. Another area where the James Webb Telescope is revolutionizing our understanding is in the study of exoplanets, planets that orbit stars outside our solar system. Before its launch, scientists had identified thousands of exoplanets, but studying their atmospheres in detail was nearly impossible. The James Webb Telescope has changed that. By analyzing the light that passes through an exoplanet's atmosphere as it transits in front of its star, the telescope can detect the presence of water vapor, carbon dioxide, methane, and even potential biosignatures, chemicals that could indicate the presence of life. One of its most exciting discoveries so far is the detection of water vapor in the atmosphere of a rocky exoplanet located in the habitable zone of its star, where conditions could be right for liquid water to exist. While this does not confirm the presence of life, it is a tantalizing hint that we may not be alone in the universe. The telescope's observations of our own solar system have also yielded surprising results. By studying the atmospheres of planets like Mars, Jupiter, and Saturn, scientists have gained new insights into their weather patterns, composition, and evolution. For example, the telescope has detected previously unknown storms and atmospheric phenomena on Jupiter, providing a deeper understanding of the gas giant's complex dynamics. It has also observed the icy moons of Saturn and Jupiter, such as Europa and Enceladus, which are believed to have subsurface oceans that could potentially harbor life. These observations are helping scientists plan future missions to explore these intriguing worlds in greater detail. But perhaps the most profound impact of the James Webb Telescope is its ability to inspire. Every image it captures is a reminder of the vastness and beauty of the universe. From the swirling clouds of distant nebulae to the intricate structures of ancient galaxies, the telescope's observations are a testament to the power of human curiosity and ingenuity. They remind us that despite our differences, we are all part of something much larger, a universe that is constantly evolving, full of mysteries waiting to be uncovered. As we continue to analyze the data from the James Webb Telescope, one thing is clear. We are standing on the precipice of a new era in astronomy. The discoveries it has made so far are just the beginning. With its unparalleled capabilities, the telescope will continue to push the boundaries of our knowledge, revealing new insights into the origins of the universe, the formation of galaxies, and the potential for life beyond Earth. And with each new discovery, it will challenge us to rethink what we thought we knew, reminding us that the universe is far more complex and mysterious than we ever imagined. So, what does the future hold for the James Webb Space Telescope? The possibilities are endless. It could uncover evidence of the first stars, shedding light on the era known as the cosmic dawn. It could detect signs of life on a distant exoplanet, answering one of humanity's oldest questions. Are we alone? Or it could reveal entirely new phenomena that we cannot yet imagine. Whatever it discovers, one thing is certain. The James Webb Space Telescope will continue to change everything we know about the universe, one observation at a time. The journey of discovery is far from over. As we peer deeper into the cosmos, we are reminded of how much we still have to learn. The James Webb Space Telescope is not just a tool for exploring the universe, it is a symbol of humanity's boundless curiosity and our relentless drive to understand the world around us. And as we continue to explore the mysteries of the cosmos, we are reminded that the universe is not just a place of darkness and emptiness. It is a place of wonder, beauty, and infinite possibility. The James Webb Space Telescope is our window into that wonder, and its discoveries will inspire generations to come.